Welcome to our news channel, a galaxy far, far away. In our galaxy, far, far away, there's a spacecraft that has run out of fuel. This revolutionary machine has changed the way we think about planets forever. Today, to talk about the spacecraft, we're going to bring in an expert, Emily. Explain the Kepler telescope and how it started.
The Kepler spacecraft is a low-cost orbital telescope that locates planets in the Milky Way galaxy. On March 6, 2009, the Kepler spacecraft was launched into space. It was an observatory space mission that was used to find planets outside of our solar system. The spacecraft surveyed the sky for 9.5 years until it ran out of fuel. Also, it determined potential habitable planets.
A habitable planet has similar temperatures to Earth, which therefore allows liquid water. So basically, the Kepler spacecraft job was to see if there are any other planets that are orbiting said stars, just like Earth. The Kepler Space Telescope solved the problem of not knowing the amount of planets in the galaxy.
My friend Sebek said Kepler showed me there are really planets out there of all different kinds, like lava planets or ocean planets.
What did the Kepler spacecraft actually do?
Kepler was able to locate 530,506 stars and 2,662 planets around those stars. Some of these planets are in the habitable zone as well.
I thought Earth was the only habitable planet.
Exactly, that is the point of this whole mission. Although we only surveyed a part of the Milky Way, when we multiplied our findings by the amount of space there is in the Milky Way, we got a total number of planets in the billions.
What? How does this telescope even work?
To find planets, the Kepler spacecraft would stare at thousands of stars for several years, waiting for the stars to blink when a planet passed in front of them in orbit. The initial group of stars the spacecraft looked at was a patch of sky close to the Northern Cross. The machine measured the brightness of the stars every half an hour and looked for those blinks. It was like trying to detect a flea crawling across a car headlight when the car was 100 miles away, William Baruch said.
So how big is it?
It was the largest telescope that has ever been sent into space.
While doing some research, I learned about the massive amount of data it collects. How does this data get transmitted to Earth?
We use a system called downlink.
I also learned that the Kepler sweet spot had to be a certain amount of light years away from Earth, so that the sun didn't block its view, but also close enough so that the downlink would work.
Yes, that's correct.
What are the benefits of the discoveries of this technology, Emily?
Contrary to what was thought before this technology, planets are very abundant in our galaxy. The spacecraft, unfortunately, has only discovered a fraction of the planets in our galaxy, but it showed that there is so much more for us to discover.
Also, I'm interested in aliens. This spacecraft has shown that there's a possibility for other habitable planets in our world. How cool is that?
It's fascinating. Earth is in this Goldilocks zone with perfect temperatures and liquid water. The nearest possible habitable planet with Kepler's findings could only be 11 light years away from Earth. Now, Earth 2.0 hasn't been discovered yet, but we could be close.
Wow, the mission has truly transformed my view of this universe. Now, as much as I would love to get into all the details about Earth's 2.0 candidates, I must know, what are the limitations to the design?
Oh, a first limitation is the fuel. Due to gravity, it is not an easy task to figure out when the fuel will run out. And before we came to the end of the mission, we had to make sure we had enough fuel to send back all the data. However, with no gas gauge, the engine stoppage was unpredictable.
Ah, I see. But I recall hearing of a time back in 2013, I think, when one of their wheels broke down.
Yes, it is true, but it wasn't so much of a limitation, but rather a setback that led to a greater improvement. It started when one of Kepler's reaction wheels broke down.
Ah, yes. Oh, sorry for the interruption. But for those of you who don't know, a Kepler wheel is a device that maintains the observatory position in a place so it can observe the stars in the same position, to stare.
Yes, so when the first wheel broke down, the backup wheel came into place. In 2012, though, another wheel broke down, so it was functioning on 3 wheels, which is risky.
Since that happened 5 years ago, and the telescope just stopped, how did you keep it running?
We actually had to use the pressure of the sunlight to keep it balanced, which a very few smart engineers came up with.
Thank God for the NASA engineers and the sun. To end things off, I would love to discuss a few more of the plethora of findings the Kepler spacecraft has made.
Of course. Let me start by saying that before the Kepler spacecraft, NASA did not know that there were many planets outside of our solar system. But now we know that many planets are between the sizes of Neptune and Earth. 20 to 50% of the stars visible in the night sky are likely to have small, rocky planets similar to Earth located within a star's habitable zone. We know now that the formation of a planet is not a random occurrence, but rather a common aftermath of a star formation. The Kepler spacecraft also observed many beautiful sights that help understand our galaxy so much better, such as a multitude of supernovas. And Neptune is in a dance with its two moons, Triton and Nereid.
Wow!
Scientists are going to take another decade searching Kepler's data to find any unnoticed discoveries.
So just because Kepler ran out of fuel, it's not the end of Kepler's discoveries? Well, thanks for coming, Emily, and I look forward to hearing from you, and please keep me updated on all of Kepler's discoveries.
I'll be sure to.